Hello, CC friends. Welcome to the Math Map Division. So we're going to do a couple videos for this one. As I said, I'm kind of functioning, pardon the math joke. Um, I'm functioning about 2 weeks ahead with my kids. That way I get to kind of see it, at least in the lower levels, and then I glance over the complex. So the division was really fun for those of you who are working the fractions domain with your kids at home from online, because I don't know what happened, but it's definitely a shift for me where I was barely making it through maybe 8 pages because it was way above my daughter's head. Now, granted, she's third grade, not fourth grade, but figured I'd still try it so that way we could do it again when the actual pamphlets come out next year. But I found a distinct difference, so I know that it's still kind of under development for the online versions. And I think if you are planning to use it or have already printed it for this week, it's really cool because I feel like it's a lot more on a younger child's level and showing them some more basic principles that are going to be necessary for future in math. Not that it wasn't good before, but it was so advanced. There was a lot of stuff I really had to skip through or just do with her in the answer key, and it was very almost comparable to the complex without the I. Like, last week did a lot with the greatest common factor. It was very, very, very intense for a third or fourth grader who's just coming into this. So anyway, I hope you have fun with that. I'm not going to talk a whole lot about things that I saw in the naturals and in the fractions because a lot of it is still in complex, but a higher degree. In future lessons, or future videos, I will also include some feedback as we work further through if there's anything my kids have struggled on and so forth. So, this is going to just cover pages 1 through 4, and there wasn't a whole lot in page 1. Just noting, this can be a confusing concept, but if you have the number line, what are we trying to do? We're trying to, if I'm starting at like 18, and before we illustrated multiplication as hops. So if we're skip counting by 6 3 times, we get 3 times 6 or 6 times 3. Remember, order doesn't matter in multiplication. It's important they understand that. But, we have 3 hops of length 6, and I think that's how they're doing it, right? I want to make sure I'm kind of consistent with the notation. I believe so because yes. So 3 hops of length 6, 3 times 6, and we're seeing that they can count that. So it's, as we are doing division, we're just hopping backwards and trying to figure out what was the amount in each partition. So if you're dividing cards, you're dividing candy between 3 people, how many pieces are they each going to get? They're each going to get 6, and vice versa. If it was 6 people, they're going to get 3. And how I teach my kids, because they know the skip counting songs, especially my older child, is, before, if we did like 3 times 5, we go 3, 6, 9, 12, 15, and then they knew it was 15. Now I say, if it's 15 divided by 3, how many skips do we have to do to get to 15? And this also helps when they're dividing and trying to figure out, is it evenly divisible or not? Because if they don't land on the number, but they pass it in their skip counting song, then they know it's not evenly divisible. So if I was saying, what is 15 divided by 3? I'd say skip count by threes, land on 15. So they would go 3, 6, 9, 12, 15. And then they would say, oh, it's 5. And if they skip count past that, then you can backtrack and say, whoop, you passed it, you missed it. And it's a cool way for the younger kids to kind of teach them that concept. So anyway, that's that. Long division. Hopefully we all remember it. I will, I love that they talk about the different types of division symbols. There's so many. I'm not going to write them all out here on the board because the book is pretty self-explanatory. Don't feel bad if you've never heard some of these terms before. I have never heard what the actual division symbol was called, and there's just different things that are probably going to be pretty new. So don't feel bad that if you're like, what was that? And of course, as always, post comments. And a lot of people who are probably going to watch this video all know me from my CC community. So please feel free to email me, text me if you have more math questions. So there wasn't a whole lot in this. The one thing I did want to show that is going to be very instrumental for them as they're moving up in grade levels is, there's a big difference between having something like this and teaching them to cancel. These are called factors. So factors are things that are separated by multiplication. So if you have the same factor in the numerator and denominator of a fraction, you can cancel it. Now I'm going to show you another scenario where you cannot do that. If I had 3 plus 6 over 6 plus 5, and you're not going to see this necessarily, but as we're dealing with variables, letters, i's, all these different things, if it's separated by pluses or minuses, they are called terms, not factors, and I cannot do that. That is an illegal math move, okay? Because they're really illustrating the unit fraction, and that's 6 over 6, or it would be 3 over 3, 5 over 5, I over I, x over x. If you have two of the same thing, but it's all multiplied, we can cancel it. But 3 plus 6, as we see, because we know that to add fractions, we have to have common denominators. So we can't just cancel. Or another thing would be like if you had, let's say you had 3 over 5 plus 5 over 5, okay? I can't say, oh, I have a 5 and just cancel that. Like it can get really confusing for them. So just make sure it's very clear. This is only when these are multiplications on the top and bottom that we can start canceling factors. That's why we do factoring, which is a very important higher level math concept. And that leads into something I saw on page 3 that I just wanted to note is very important and awesome, that they're teaching it so young. And if you see, this is in the complex, and there wasn't as much of this in the lower levels, but it's not really necessary there. But complete the factor patterns. And it had where they work backwards and they're kind of they're seeing a process, and it's really cool because it's they're counting. So like your first one ends in, I'm not gonna write the whole thing out because it'll be a bit time consuming. Let's just do, actually let's do the first one. X plus 2, or x squared plus 2x plus 1 equals x squared plus 2 times 1 x plus 1 squared, and I ran out of room, and this equals x plus 1 squared. So this is what we call perfect square. It's like backwards distributing. Remember we talked about FOIL last week, where if I had two things, so x plus 1 squared is really x plus 1 times x plus 1. And a lot of kids forget that, and adults too. And we think it's just x squared plus 1 squared. But again, this is a plus. If this was a multiplication, if this was a time symbol, then the two would distribute to both for multiplication by the laws of exponents. And you'll see it a little bit next week when you hit the exponentiation one. But we cannot distribute that to the two terms. This is this times itself up here. So we do our first x squared times our outside, so plus x, times our inside plus x, times our last. Remember the FOIL? First, outside, inside, last. So plus 1. And then we talked a little bit. This is if you've seen all the videos, and if not, look back. It's all on the same channel. We would collect the like terms. We have x plus x. So we have x squared plus 2x plus 1. So it's that. So it matches this. Factoring is one of the biggest hangups I've seen in higher level math students. It just boggles their mind, and it really holds them back in the higher levels of math, because you have to not only be able to factor this, you have to be able to factor stuff with trigonometric functions and all kind of things in it. It's really important you understand the patterns. A lot of it comes from memory, working the problems. So the way they're doing this, where They're showing just, at least on page 3, they're showing just the process of, oh, this is what it would look like if it was a perfect square, plus 1, and plus 2, plus 3, plus 4, and you're starting to see a pattern. And as I record more videos, I'll do the other 3 probably. I'll post them tomorrow morning, because I'm going to try to do 4 videos a week that are shorter. This one's a little longer because I start blabbing. But I'm going to try to do 4 videos a week, and each one covers 4 pages, just the little highlights that I see in there. And I think there, if I remember right, there is a progression that's showing more and more with the factoring. So it's really cool. Last thing is for roots, and I know they're going to go over this more. Definitely don't, there's a lot of things that are going to feel very foreign and completely overwhelming. So that's the other reason why I'm highlighting things that I think would be really important for your 7th graders to know, or even if you're seeing some of this stuff in the lower levels, but to a lesser extent. It's very important to know that how to simplify a square root, and you're going to get more into it. But on page 3 again of the complex, this was in there, and it was really good. So like if you had the square root of 8, recognizing we talked about prime factors last week, this is the square root. By the way, when there's nothing here, it's a square root. It's assumed because that's the most common one. And we know 8 from last week, 8 is 2 times 2 times 2, right? When we break it down into those prime factors. So 2 times 2 is 4, and that's a perfect square. So I teach my kids, and I've always taught my students, look for little pairs underneath of your radical sign. So if it was even more, you would be looking for pairs, or if there were 2 3s, 2 5s, and associated with cards, because kids always love playing card games, stuff like that. You're looking for pairs. If you have a pair, you can pull 1 out. So this pair gave me 1 on the outside, and I'm left with 1 still on the inside. So I liked that it was breaking that up, and it's like circle the pairs. So that's a good first step in that. Anyway, that's all I have for this video. If there were more things in that section that were confusing, again, please feel free to comment or reach out to me. Have a wonderful day. Thank you for joining.